Okay, so polygons in the coordinate plane. So I can classify polygons and calculate the perimeter of a figure in the coordinate plane. So let's talk about what is a polygon. So in geometry, a figure that lies in a plane is called a plane figure. Recall that a polygon is a closed plane figure formed by 3 or more line segments called sides. You can't do 2 because it won't close off ever. Each side intersects exactly 2 sides, one at each vertex, so that no 2 sides with a common vertex are collinear, meaning they're not on top of each other. You can name a polygon by listing the vertices in the consecutive order. So you start in a consecutive order, meaning alphabetical order there. So this is polygon A, B, C, D, E. So A, B, C, D, E. Each point here is known as the vertex. So this one is vertex C, vertex B, vertex A, vertex E, and vertex B, D. And side lengths are named by the segments. So this one's side BC, this one's side AB, segment AB. Do you see that all being there? So this is, just as a reminder, this is side AB, and it's a segment, so you put the segment hat. So again, this is kind of a review for your quiz if you're thinking about it. When you do a segment, remember it doesn't have arrows because it doesn't go both ways, so you just put the segment hat on it, and you always use 2 points, okay, 2 capital letters. Or if it's a line, the hat has arrows on the side, right, meaning that there's lines. That can use 2 capital letters or a single lowercase letter to name a line, right? Or if it's a ray, you use the 1 arrow, right, to the right. But this doesn't have any arrows, so just a little review of that. Since this is in a plane, could be in plane A, B, C. To name a plane, you use 3 capital letters, right, that are not collinear. So A, B, and C do not lie on the same line, so that's why you can use it. But it's sitting on the plane of the whiteboard, we'll call it, okay? So as a little review for naming planes and stuff. So this is called vertex E. If you're wondering, each one of those points is a vertex. Okay, anybody else need the hole puncher? I can give her one. All right, when you're ready, go ahead and flip to the next page then. As a reminder, to be eligible for retakes, when the tests come up, you need to be getting all your homework turned in. You can have 1 missing assignment, that 1 get out of jail free. Otherwise, you're not going to be able to take the test, and those need to be in 2 days before the test. Now, granted, I don't know exactly when the first test is going to be at this point. Probably coming up in the next week or 2, though. All right. So if you're missing or you're behind on homework, start getting that into me. All right. You'll get full credit for it, but get it into me so you have that eligibility. Okay, features of polygons continued. The number of sides determine the name of a polygon. You should know this stuff. You probably learned it in elementary school but have forgotten it at this point. But it is not new to you. So 3 sides, triangle. Tri means 3. 4 sides, quadrilateral. Quad means 4. 5 sides, pentagon. Penta means 5. 6 is hexagon. Hexa means 6. 7 is heptagon. 8 is octagon, 9 is nonagon, 10 is decagon, and 12 is dodecagon. When we get any more than that, or 11, or 13, 14, 15, you can just call it a 13gon, or a 11gon from there. But these ones have specific names you must use. You may not say a 6gon, okay? Do we all understand what I just said there? So what this is saying here is if it had 20 sides, you would just call it a 20gon. Okay, that's what that means there. And it also says that down there with 14, so 14 is a 14gon. A polygon is convex. That's important that you know that. When no line that contains the side of the polygon contains a point in the interior of it. The polygon. And a polygon that is not convex is called concave. So it is not considered a polygon if it's not considered a real polygon, I guess, if it is not convex. So what I think of when I think of convex and concave, you know, like a cave you can go into. If there's a spot that you can like literally walk into like a cave, so do you see like a person could take a little journey inside of this like polygon, right? That makes it concave. Think of like an actual cave that goes in. This is actually describing though is like if you were to draw like line segments from all of the lines, do you notice that it's going through the polygon here? You guys all see that? So if that happens at any point and it's going through, that makes it concave. That's like the actual literal definition of it. I just like to give you guys other ways of knowing things too. All right. So let's go on to naming them. So classify each polygon by the number of sides, then tell whether it is convex or concave. So first we need to count the number of sides. So this one has 1, 2, 3, 4, 5. What is a 5-sided polygon called, Paige? What is a 5-sided polygon called?
A pentagon.
It's a pentagon. And is this pentagon convex or concave? Yeah, it's like you can walk in right here, right? Also, if you were to take this line and extend it, you see how it cuts through the polygon? This line also would cut through the polygon, which makes it concave. So it's a concave pentagon. Questions on where we got those words from, I mean? Okay, so let's count up the next one. This one has 1, 2, 3, 4, 5, 6, 7, 8. So an 8-sided polygon, Dylan Keith, is what? It's an octagon. And is this octagon convex or concave?
Convex.
It's convex. There is no way you can walk into any of these. There's no like cave to walk into. Also, if you were to extend any of these lines, it will not cut through the polygon at any point. Okay, what is number 3, Tucker? It's an octagon again, just a different looking octagon. So it's an octagon. Is this one convex or concave, Tucker?
Concave.
You can walk in at Pac-Man's mouth. This looks like Pac-Man to me, so I'm calling it Pac-Man. Again, also, if you were to extend this line or this line, it cuts through the polygon, making it concave. Okay, Ayana. I skipped a number. What is number 4? Dodecagon?
Yeah.
It is a dodecagon. Deca meaning 10, do adding 2 to it, that's why it's a dodecagon. So dodecagon. Is this one concave or convex? It is convex. So again, if you were to extend any of these lines, it wouldn't cut through the polygon at any point. All right? What questions do you guys have about classifying polygons? If there are no questions, you guys may flip and we'll start getting into the other stuff. All right, so the next thing says, remember we're going to be finding the perimeter in the coordinate plane. To find the perimeter, you take the sum of all the side lengths. That means add up all the sides. So sum means add. So add up all the sides. So when a figure is graphed on a coordinate plane, you can use the Pythagorean theorem to find the distance of each side. You can use the Pythagorean theorem. You could also use, if it's not a right triangle, what else could you use to find the distance on a coordinate plane? What's the other thing you could use? As a more review here.
The equation.
Good. What equation, sorry?
What would you say?
What did you just say? I'm sorry, I just
The
said good.
equation.
Which equation?
Distance formula.
The distance formula. I don't know if you said that or not. I'm sorry if you did. But yes. But the Pythagorean theorem is a squared plus b squared equals c squared. So as a reminder, this can only be used in right triangles. So if you don't have a right triangle, do not use it. So if you don't have a right triangle, you're going to have to use the distance formula, as Melinda said. Again, reviewing a little bit for your quiz by doing this, so make sure you're paying attention. And the distance formula is the change in x squared plus the change in y squared. Remember that the distance formula and the Pythagorean theorem are hand in hand. One is based off the other. It does not matter. If you know one, you should be able to figure out the other, basically. They're basically the same, just written two different ways. Remember that little triangle there means the change in x means the distance of the x coordinates, and then the change in y is the distance of the y coordinates. Okay, so go ahead and get that stuff written down, and then we'll get into our first example here. Okay, it says, find the perimeter, which means add up all the sides, of triangle ABC with vertices -2, 3, B is 3, -3, and C is -2, -3. So this one's already plotted for you. Some of them are not going to be plotted for you. Some of you are struggling with plotting vertices. I learned that while grading your guys' segment homework, because the first two were coordinate planes where you had to plot points, and I was a little bit worried. So if you can't plot points, come see me. But anyways, do we have to notice this here? Can we use the Pythagorean theorem in this one? Yeah. Don't we know this is a right triangle based on it being a vertical and horizontal line? Remember, they make a perpendicular, which means makes a right angle. Perpendicular has opposite reciprocal slopes. Well, this is an undefined slope and this is a zero slope. Those are opposite reciprocals of each other. So we can find this distance without using the distance formula. So what is the distance from A to C? So what is the distance from A to C? Okay. What is the distance from C to B? What is it? 5? So these are both legs because they form the right angle. Remember, the side opposite the right angle is called the hypotenuse.
Teachers, pardon the interruption. These students attending the discipline assembly are returning back to class at this time. Thank you.
All right, so remember the side opposite the right angle is called the hypotenuse, so we're going to need to find the hypotenuse using the Pythagorean theorem. Remember, a squared plus b squared equals c squared is leg squared plus leg squared equals hypotenuse squared. So I do 6 squared plus 5 squared equals c squared. 6 squared is 36. 5 squared is 25. How do I undo something that's squared? Because c isn't alone yet. So what do I have to do to undo something that's squared? What do I have to do? Mariah? Take the square root. That's the inverse of squaring something. So that takes off the 2 there. So we have the square root of 61 equals c. We never write things as a decimal. This is the same for your quiz today. When you get to this point, you better not be plugging in your calculator to get the decimal. You should try to do a factor tree. Does anything go into 61 though? No, that is prime. So we know that this side length here is the square root of 61. So we leave it that way. So to find the perimeter, we add up all the sides. So I do 6 plus 5 plus the square root of 61. All right, side note. Understanding like terms when it comes to radicals. To be a like term in a radical, treat it like an x. All right? So if this was x, could you do 6 plus 5 plus x? Could you add x to those? No, that would just be 11 plus x, right? It has to have the same number under the radical to be a like term. So a like term in radicals has to have the same number underneath. That is called the radicand too. Like 2 root 5 and negative 3 root 5 are like terms. They have the same number under the radical. Okay, so do not add unlike radicals. And we'll see a few of those today, but just wanted to do a side note there. So like terms in radicals means they have the same number underneath the radical. So an example of that would be 2 root 5 and negative 3 root 5. They both have a 5 underneath. So when you go to simplify this, you cannot add to the square root of 61. So you can just add these two pieces, so you get 11 plus the square root of 61 as your perimeter. So go ahead and get that written down and see what questions you have for me, because you just learned a lot of concepts in one slide. All right? So look through it, process it for a second, and see what questions you have for me. Madeline. Madison, goodness. I'm going to give you a different one for that. Didn't get hole punched well. That is the construction portfolio. I don't know 100% when it's going to be due yet. I'll let you know, Madison, for that. I'm going to say your name 100 times so I can remember it.
I thought this was a quiz. So.
No.
All right.
We're doing that at the end of the hour. So you might want to, this one didn't get hole punched well, so if you want to hole punch that yourself, that's the one that needs to be in a bound, like folder or binder type thing. I'll let you guys hopefully know by Friday when that will be due, okay? But you can't do all of the stuff that's in there yet anyways. All right. What other questions you guys have for me? Okay, let's try the next one. So it says, using the figure in the coordinate plane, find the following. The perimeter of A, B, D. So A, B, D is that triangle there. The triangle because it has 3 sides. So, is that a right triangle? Is that a right triangle? Yeah, so since it's a right triangle, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. Alana, what's the length of the segment AB? Good. And what is the length of the segment BD? Lexi? Yep. So what can we do now that we know those two things to find the length of segment AD? What can we do to find the length of segment AD? What can we do? We know 2 sides of a right triangle. What can we do? Jordan? And these are both legs, right? Because they form the right angle. The side opposite the right angle is called the hypotenuse. So we have 5 squared plus 6 squared equals c squared. I feel like we just did this problem. I was going to say. Since we just basically did this problem, I'm going to just write it up real quick here. Okay, so we take that off and we get the square root of 61 is c. Could we do a factor tree for this one? No. So to find the perimeter, you add up all the sides, and we talked about like radicals. So can we add 6 and 5 to the square root of 61? Can you add those to the square root of 61? No, it's like an x. You couldn't add that to x, so it's just 11 plus the square root of 61. Okay, see what questions you have there. That's basically the same problem we just did above, though, so that's why I went through it a little bit quicker. Sorry. And then it says find the perimeter of the whole entire quadrilateral. So the whole entire quadrilateral, A, B, C, D. So A, B, C, D is that quadrilateral there. Notice there's another triangle here. Can we use the Pythagorean theorem to find the sides of this triangle? Can we? Why not, Ayana? It's not a right triangle, is it? So if you cannot use the Pythagorean theorem, you have the lovely distance formula. So we're going to find the length of DC using the distance formula. Okay, so I put those points up there again. So we know D is at the point -4, -1, and we know C is at the point -1, -5. What is the change in X from D to C? What is the change in X, Corey, from D to C? From -4 to -1. How many is that?
3.
Good. Then, how about the change in Y from D to C? From -1 to -5? 4. So we plug those in. Distance is always positive, never make it negative. What's the square root of 25? 5, right? If you do a factor tree, that's 5 times 5, which means everything gets circled. So do we keep a radical if everything gets circled? No. So DC is 5. Okay, now we need to find, we found DC, so now we need to find BC. So let's write this all up here. So I'm going to write this all up here. This is the square root of 61, so I know what ones I know. This one we said is 5. So now we have to find BC. Okay, I'm going to stop for a second after I write up the ordered pairs. And you guys need to look at what I have up here and see what questions you have for me so far. Okay, I'm going to give you guys a few seconds to look and see what questions you have for me so far about what is happening on the board. Why am I finding what I'm finding? Do you guys know why I'm finding DC and BC? Can anybody explain why we're finding the lengths of DC and BC and AD and AB? Why are we finding all those lengths? Let's explain that first. Brandon.
Simply add them up and then get the perimeter.
Right, you need the side lengths to get the perimeter, right? So that's why we're finding it. Why aren't we using the Pythagorean theorem for number 7? Lexi?
Oh, it's not a right triangle.
It's not a right triangle. Did you have to use the Pythagorean theorem to find this length here? Could you have used the distance formula, Brandon? Yeah, you could have. So that's not one way to do things, right? But just so you guys are aware of that. So are we all clear why we're finding the distance of all these lengths? Taking a step back? Okay. So then, let's then do the same thing here. Writing up the distance formula 1,000 times, hoping that you'll know it by the time the quiz is handed to you in a couple here. Okay. Cole, what is the change in X from B to C? So from 2 to -1. 3, right? You cross over 0, so we have to add them together. So that is 3. And Dylan Daptula, is that how you say your last name?
Yeah.
Okay. What is the change in Y from -1 to -5? 4. You're on the same side, so you just look at the distance there. So we add them together. Some of you are probably thinking you can't even say my first name and you have his last name too. Sorry about that. So that's 12 plus 16. That's not 12. Somebody next time say something to me. That is 9. Don't know where 12 even came from. So we get the square root of 25. So you do your factor tree again. You look for groups of 2. We have a group of 2 5s, which means we have 5. Is there any radical left yet here? Is there any radical here? No, because there's nothing that's left without a partner. So we know this side is also 5. So the perimeter of quadrilateral ABCD is 5 plus 5 plus 5 plus the square root of 61, right? Can you add 5s into the square root of 61? Can you add that? All right, is 5 and the square root of 61 a like term? No, we talked about that on the previous slide. So we have 15 square root plus the square root of 61. All right, look at that as a total now and see if you have any questions there before we do the last 2 examples. And then I get the quiz out to you guys. Are you doing okay?
Oh, yeah.
Are we doing okay? This is a lot of stuff. There's a lot of steps. I think that if each step was individual, I think you guys would be fine. It's just like putting it all together as one can be difficult. So please ask questions. Ayana. What did you say? Okay, so Ayana asked where I got the 3 5s from. So we knew this length is 5 here because we had counted it earlier. We just used the distance formula to find this one, right? And then we used the Pythagorean theorem earlier in part 6 to get the square root of 61. Does that make sense then? Okay, any other questions? Right. The next one has you actually plot the points yourself. Be intentionally careful when plotting the points. It is such a old topic for you guys. I think sometimes you rush through it and make really silly mistakes. I think that's why most of you plot wrong. Some of you may not know how to plot. Come and see me if that's the case. But be intentionally careful when you plot your points. So when you're given a coordinates of vertices, find the length of each side. A coordinate plane is provided but may not be necessary. It may not be necessary, but I think it is important to plot them right now for you guys to understand this. So DG is 5, negative 3. So D is 5, negative 3. Then I have 5, negative 6. Bless you. 2, negative 6. And 2, negative 3. Your quadrilateral, your polygon, your whatever you're plotting should go in order of the coordinates it gives you. So do you see how it says D, E, F, G in that order? So you should always connect in that order. D to E, E to F, F to G, and then back to the original. Okay? Just as a other note here. Okay, look at this one. Is this one easier or harder than the previous problem and why? Why are we thinking it's going to be easier? Why is it going to be easier, Jordan?
Because you only have to find the distance of one side.
Why do you only have to find the distance of one side?
Because all the sides are the same.
All the sides are the same. We're assuming it's a square. Okay. Why else would somebody say this is easier? Brandon?
Because you can just count the units, you don't have to use the distance formula.
Why can you just count the units? What makes this one countable versus like the one on the previous slide where we got the square root of 61? What makes that different? What makes this one different? Why can we just count them? Who can explain why you can just count them versus the other ones on the previous slide that we had used the distance formula? Alana?
It's just on a straight line. You gotta like through.
Good. it's a vertical or horizontal line. So if it's a vertical or horizontal line, you can just count them. If they're slanted, so they're like cutting through the boxes, you're going to have to use the distance formula. But you can see here that these all are 3. So to find the perimeter of this one, all you have to do is 3 plus 3 plus 3 plus 3. So the perimeter of that one is 12. So do you have questions why that we could do that with that versus like getting the square root of 61 or the distance formulas where we had to get 5? Does anybody have a question on that? And I'm sorry if you feel like I'm talking down to you. I just have to make sure that I'm saying notes in a way that everybody can understand. And I know some of you probably understood that way before what I said, but we're all at different levels in this class, so I need to make sure I'm hitting all of you. I'm not trying to ever do that for you. Right, do we have any questions there? So we have one more example, and then I'm going to get you the homework that you can do after your quiz. Plus you have your construction portfolio. Remember I said that there's the step-by-step construction site on the Google Classroom. I will make sure that stays towards the top after today. Right now I want that quiz to stay towards the top, but I'll make sure to move that towards the top so you constantly have it up there in the refreshing spot, okay? All right, intentionally plot D, E, F. And notice it goes D, E, F. So you'll connect D to E, E to F, and F back to D. Okay, so go ahead and make sure you're being very careful. Make sure you don't plot 4, 0 on accident. Bless you. So I connected D to E, because they're next to each other, E to F, because they're next to each other, and F back to D. All right? Does form a triangle. Is this a right triangle? No, so Tucker, what can't we use if it's not a right triangle?
The Pythagorean theorem.
Right, so we cannot use the Pythagorean theorem. But we do need to know what DE equals, EF equals, and F or DF equals. So we're going to have to do different things for that. For DE, do we have to use the distance formula? No, Ayana, what is the length of DE? It is 6. You can just count that one. The other two, unfortunately, we're going to have to use the distance formula. They look like this might be an isosceles triangle, but we're not going to assume anything. We'll use the distance formula twice. Isosceles triangle means that it is has 2 congruent sides, at least 2 congruent sides. So Madison, for EF, what is the change in X from 6 to 3?
3.
3, good. And Melinda, what is the change in Y from 4 to 0? 4. And it's always positive, so if you think -4 at first, just make it positive, okay? That's completely fine. I feel like we've done this 100 times now. Yes, Melinda. Or Melinda. Sorry, Madison. I know you're not Melinda. Looked right through you to that. Yes, Madison.
If we got an answer for EF, wouldn't it be the same as EF since they're like the same?
They do look the same. I'm going to still do the process again, but yes, it's the same. But I am going to do the process again, just so you guys understand the process if they aren't all the same, okay? But yeah, you are right. So the square root of 25, again, is 5. We've done this now a couple times. Then as Madison said, yes, they are the same, but I'm still going to do it again just so you guys have that process in your notes so you guys know exactly what to do in different situations. Does that make sense? So EF was 5. Also, it's good practice for your guys' quiz today, and you have to use the distance formula. Oops, I need to determine the change in x and change in y. So what is my change in x, Brandon? From 0 to 3. What is that? 3. My change in y, Dylan Keith? Good. So we get the same thing. 9 plus 16, which is the square root of 25, which is still 5. All right, so what are we going to do now to find the perimeter then? Add them all together. So the perimeter is 5 plus 6, which is 16. All right, look at that and